Hello, saver. Whether you're saving for that trip to the tropics or saving for an emergency, now is the time to take advantage of Wells Fargo's savings options. Wells Fargo offers savings accounts that can help you save towards your goals. So, what are you saving for? Visit a Wells Fargo branch or wellsfargo.com/save to open a savings account today.
Wells Fargo Bank, N.A., member FDIC.
Fargo, the new virtual assistant from Wells Fargo, makes banking faster and easier. Like this.
Fargo, what's my checking account routing number?
And this.
Fargo, turn off my debit card.
And this.
Fargo, what did I spend on groceries last month?
And that's just the beginning. Do you, Fargo? You can. In the Wells Fargo mobile app. Learn more at wellsfargo.com/getfargo.
Terms and conditions apply. Your mobile carrier's availability and message and data rates may apply. Wells Fargo Bank, N.A., member FDIC.
This is SpaceTime, Series 24, Episode 24. Coming up on SpaceTime, the most distant black hole ever seen, a successful Australian test for a revolutionary new type of rocket engine, and Starliner's next test flight to the International Space Station now slated for April. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
Astronomers have set a new record for the most distant quasar ever found. The quasar, dating back some 13.13 billion years, is 1,000 times more luminous than the Milky Way galaxy and is powered by the earliest known supermassive black hole, a true monster, more than 1.6 billion times the mass of the Sun. The newly discovered quasar, designated J0313-1806 and reported in the Astrophysical Journal Letters and on the pre-press physics website archive.org, doesn't just provide new insights into the evolution of massive galaxies in the early universe. It also raises profound questions about how such massive black holes could have existed just 630 million years after the Big Bang. And that's a point underlined by the study's lead author, Fringe Wang from the University of Arizona, who says black holes created by the very first massive stars simply could not have grown that large in only a few 100 million years. The most distant quasars are crucial for understanding how the earliest black holes formed, and for understanding cosmic reionization, the last major phase transition of the universe from the cosmic dark ages, before the first stars. Quasars are powerful jets of mass and energy generated by black holes feeding on surrounding material. As matter falls into a black hole, it forms an accretion disk around the black hole's event horizon, a point of no return, beyond which material falls forever into the singularity, a place of infinite density and zero volume where science's understanding of the laws of physics breaks down. Material on the accretion disk is ripped apart at the subatomic level by friction and gravitational forces, releasing huge amounts of energy radiating out across the electromagnetic spectrum. The amount of energy emitted by quasars is enormous, with the most massive examples, such as this one, being visible right across the entire universe. J0313-1806 was first spotted in data from the Pan-STARRS and Euclid Hemisphere Survey, with follow-up spectra from the Keck and Gemini North telescopes to measure the size of its central supermassive black hole. Measurements from spectral lines that originate from the gas surrounding the quasar's accretion disk allowed astronomers to determine the black hole's mass and study how its rapid growth influences its environment. For such distant quasars, the important spectral lines are redshifted to near-infrared wavelengths by the physical expansion of the universe over the past 13.8 billion years. The Keck and Gemini North observations uncovered an extremely fast outflow emitting from the quasar in the form of high-velocity winds travelling at 20% the speed of light. The energy released by such an extreme high-velocity outflow is easily large enough to impact star formation in the entire quasar-host galaxy. As for the galaxy itself, well, it's undergoing a spurt of star formation, producing new stars 200 times faster than the Milky Way. The combination of this intense star formation, the luminous quasar, And the high-velocity outflow makes J0313-1806 and its host galaxy a promising natural laboratory for understanding the growth of supermassive black holes and their host galaxies in the early universe. This is SpaceTime. Still to come, NASA's Mars helicopter phones home, and a successful Australian test of a revolutionary new rocket engine. All that and much more still to come on SpaceTime. NASA's Mars Ingenuity Helicopter has phoned home, letting mission managers at the Jet Propulsion Laboratory in Pasadena, California know that it's arrived safely on the red planet's surface. Over the next month or two, the tiny 2-kilogram drone will be lowered down onto the surface of Jezero Crater from its transport dock on the underbelly of NASA's Mars 2020 Perseverance rover. It'll then begin its historic mission to undertake the first ever helicopter flight on another world. The downlink, which arrived at JPL after being relayed through the Mars Reconnaissance Orbiter spacecraft, indicates that both the helicopter and its space station, a module on the rover that stores and routes communications between the rotorcraft and Earth, are operating as expected. The tiny chopper's powered by 6 off-the-shelf lithium-ion batteries. They're now being fed additional charge from the Perseverance rover. That's a process which will be repeated numerous times over the next few months, as long as the helicopter's docked with the rover. But once Ingenuity is deployed onto the Martian surface, the helicopter's batteries will be charged solely by its own solar panel. Once Perseverance deploys Ingenuity onto the Martian surface, the helicopter will have a 31 Earth Day experimental flight test window. If Ingenuity survives its first bone-chilling Martian nights, temperatures dip down as low as minus 90 degrees Celsius, the team will proceed with the first flight of an aircraft on another world. If Ingenuity succeeds in taking off and hovering during its first flight, over 90% of the project's goals will already have been achieved. And if the rotorcraft lands successfully and remains operational, up to 4 more flights will be attempted, each one building on the success of the last. Next-generation rotorcraft, the descendants of Ingenuity, could add an aerial dimension to future exploration of the red planet, offering unique high-definition reconnaissance capabilities not provided by current orbiters high overhead or by rovers and landers on the ground. This is SpaceTime. Still to come, a successful Australian test for a revolutionary new rocket engine, and Boeing's Starliner to undertake a second orbital test flight in April. All that and more still to come on SpaceTime.
Hello, Saver. Whether you're saving for that trip to the tropics or saving for an emergency, now is the time to take advantage of Wells Fargo's savings options. Wells Fargo offers savings accounts that can help you save towards your goals. So, what are you saving for? Visit a Wells Fargo branch or wellsfargo.com/save to open a savings account today.
Wells Fargo Bank, N.A., member FDIC.
An Australian-developed rotating detonation engine has been successfully tested by RMIT. The ground demonstration was undertaken at RMIT's custom-designed engine test cell. Rotating detonation engines are 25% more efficient than conventional rocket-powered or air-breathing jet engines. That's because the flame front travels as a continuous supersonic shock wave through a ring-shaped combustion chamber or combustor, turning individual detonation pulses into a continuous thrust. Once started, the engine is a self-sustaining cycle of detonation waves, travelling around the combustor at more than 2.5 kilometres per second. Rotating detonation engines are both more compact and produce greater fuel efficiency than existing jet and rocket engines. This new engine was designed by RMIT University engineers and developed in association with the University of Sydney, the Universität der Bundeswehr in Germany, and Defentex. But the development hasn't been easy. Modelling the fluid dynamics of the combustor ring for optimal performance and predicting the exact ratios of propellant and oxidizer injection into the combustor were all key areas that needed to be overcome during the development phase. The team are now working to develop a 3D actively cooled version of the prototype then integrating the engine into an aircraft, and ultimately undertaking test flights. We'll keep you informed. This is SpaceTime. Still to come, April 2nd slated as the potential launch date for a second orbital test flight of Boeing CST-100 Starliner. And the vernal equinox and the constellations of Taurus the Bull and Leo the Lion are among the highlights of the celestial sphere in March on Skywatch. April 2nd has been slated as the potential launch date for a second orbital test flight of Boeing CST-100 Starliner spacecraft to the International Space Station. The new unmanned test comes in the wake of a disastrous first orbital test flight back on December the 20th, 2019, which was full of software issues, resulting in the spacecraft failing to reach the space station and almost burning up on re-entry. The issues included an 11-hour offset on Starliner's mission clock. That caused the spacecraft to compute that it was in an orbital insertion burn when it wasn't. And that in turn caused the attitude control thrusters to consume more fuel than planned, preventing it from reaching and docking with the space station. As mission managers were trying to cope with that issue, they detected another problem. This involved the thruster firings needed to safely jettison the Starliner's service module before atmospheric re-entry. The service module software error would have incorrectly translated the jettison thruster firing sequence. Had it not been caught before it initiated, it would have led to the destruction of the spacecraft. Boeing can't begin transporting astronauts to and from the space station as part of NASA's Commercial Crew Program until the second orbital test flight's completed successfully. The mission profile will see Starliner launched on a United Launch Alliance Atlas V rocket from Space Launch Complex 41 at the Cape Canaveral Space Force Station in Florida. It'll then dock with the space station automatically and then return to Earth, landing on the White Sands Missile Range in New Mexico about a week later. If the second test flight goes well, the first manned flight of the Starliner to the space station could take place in September, with the first crew transfer flight then slated for November. Meanwhile, SpaceX Crew Dragon 2 spacecraft is now preparing for its third manned flight to the orbiting outpost. This is SpaceTime. Still to come, March Skywatch.
Hello, Saver. Whether you're saving for that trip to the tropics or saving for an emergency, now is the time to take advantage of Wells Fargo's savings options. Wells Fargo offers savings accounts that can help you save towards your goals. So, what are you saving for? Visit a Wells Fargo branch or wellsfargo.com/save to open a savings account today.
Wells Fargo Bank, N.A., member FDIC.
And time now to turn our eyes to the skies and check out the celestial sphere for March on Skywatch. Happy New Year! Well, it would be if this was ancient Mesopotamia or Rome. That's because March was the first month of the new year, going back to the earliest concept of celebrating New Year's Day at the time of the vernal equinox, around 2000 BCE. See, the ancient Roman calendar, which had just 10 months, designated March 1st as the new year. That 10-month calendar is still reflected today, with the name September or Septem being Latin for 7, October or Octo meaning 8, November or Novem 9, and December or Deci meaning 10. It wasn't really until the Gregorian calendar that January 1st marked the start of the new year. But in the beginning it was mostly Catholic countries that adopted it. Protestant nations only gradually moved across, with the British, for example, not adopting the reformed calendar until 1752. Prior to that date, the British Empire and its American colonies still celebrated New Year's Day on March 25th. Highlight of the month is the March equinox, which this year takes place at 20:37 on the evening of Saturday, March 20th, Australian Eastern Daylight Time. That's 5:37 on the morning of Saturday, March 20th, US Eastern Daylight Time, and 9:37 a.m. Greenwich Mean Time. For our listeners in the Northern Hemisphere, it means the vernal equinox, the start of spring, while those south of the equator it's the autumnal equinox, meaning a move into autumn. The day marks the point in Earth's orbit around the Sun when the planet's rotational axis means the Sun will appear to rise exactly due east and set exactly due west to someone standing on the equator. It means almost equal hours of darkness and light. In fact, the very word equinox is derived from the Latin, meaning equus or equal, and nox meaning night. It all comes about because Earth's rotational axis is tilted at an angle of around 23.4 degrees in relation to the ecliptic, the plane created by Earth's orbit around the Sun. That axial tilt is always pointed at the same position in the sky, regardless of Earth's orbital position around the Sun. So, on any other day of the year, either the northern or southern hemisphere is tilted more towards the Sun. But on the two equinoxes, usually around March 21st and September 23rd each year, the tilt of Earth's axis is directly perpendicular to the Sun's rays. However, there's a complication called precession. This causes Earth's spin axis to wobble ever so slightly, just like the axle of a spinning top. The rate of precession is only about half a degree per century, so people don't notice it on human timescales. And because the direction of Earth's axis of rotation determines at which point in Earth's orbit the seasons occur, precession will cause a particular season, for example the Southern Hemisphere autumn, to occur at a slightly different place from year to year over a 21,000-year cycle. At the same time, Earth's orbit itself is subjected to small changes called perturbations. See, Earth's orbit's an ellipse, and there's a slow change in its orientation which gradually shifts the point of perihelion, Earth's closest orbital position to the Sun. Now, these two effects, the precession of the axis of rotation and the change in the orbit's orientation, work together to shift the seasons with respect to perihelion. And because we use a calendar year that's aligned to the occurrence of the seasons, the date of perihelion gradually regresses through a 21,000-year cycle. And there's another complication. Britain and Australia and some of the other Commonwealth countries start their seasons on the first day of the month, what are referred to as meteorological seasons, rather than on the solstices and equinoxes, which are referred to as astronomical seasons. So that means Australia's autumn officially began on March 1st rather than on the day of the March equinox. Meteorological seasons are used because it makes it easier for meteorologists and climatologists to break the seasons down into more exact 3-month calendar groupings for comparing seasonal and monthly statistics. And a special thanks to Michael Haynes for his help with the background. The moment of the March equinox is also important in astronomy because it's used to define the celestial coordinate system of right ascension and declination. In astronomy, the celestial coordinate system is the astronomical equivalent to the latitude and longitudinal coordinates used on Earth's surface. It's used to specify the position of objects in three-dimensional space and the direction of those objects on the celestial sphere, the imaginary globe surrounding the Earth. In other words, it lets scientists determine the position of a celestial object, such as a satellite, a planet, stars, galaxies, and so on. Right ascension, which uses the symbol alpha, is the angular distance measured eastwards along the celestial equator from the vernal equinox. On the celestial sphere, it's analogous to terrestrial longitude. Declination, which uses the symbol delta, measures the angle north or south of the celestial equator, and so it's the celestial equivalent to terrestrial latitude. Marking the vernal equinox and setting the western evening sky this time of year is one of the oldest recognised constellations in the heavens, Taurus the Bull, so named around 6,000 years ago. In Greek mythology, Taurus represents the king of the god Zeus. Zeus lusted after King Agenor's daughter Europa, who was looking after a herd of cattle. Now, being a god and with godlike powers, Zeus decided to transform himself into a powerful white bull so that he could get closer to the beautiful Europa. Now, once transformed into a bull, Zeus convinced Europa to climb on his back, and he then carried her off to the island of Crete. Taurus's head is represented by a dominant V-shaped grouping of stars. The bright reddish star in the group is Aldebaran, an orange giant 1.5 times the mass of the Sun, located 65 light-years away. A light-year is about 10 trillion kilometres. The distance a photon can travel in a year at 300,000 kilometres per second, the speed of light in a vacuum, and the ultimate speed limit of the universe. Aldebaran is the 14th brightest star in the night sky and the closest bright star to the point of the vernal equinox. In ancient Arabic, Aldebaran's name means the follower, as it appears to follow the 7 sisters of the Pleiades. It's also the first of the 4 royal or guardian stars identified by the ancient Mesopotamians. Now, that V-shaped grouping of stars near Aldebaran is known as the Hyades. It's the nearest young open star cluster to Earth, located just 153 light-years away. Between Aldebaran and the Orion constellation, you'll see a bright red star. That's Betelgeuse, the ninth brightest star in the night sky, these days more commonly called Betelgeuse. If you turn to the north now, you'll see the two bright stars Pollux and Castor, which represent the northern constellation of Gemini, the twins. In Greek mythology, they were brothers who travelled with Jason aboard the ship Argo in search of the Golden Fleece. Pollux is an orange-hued evolved giant star, located 34 light-years away. It has about twice the Sun's mass and is bloated out to around 11 times the Sun's diameter. In 2006, an extrasolar planet or exoplanet, designated Pollux b, was discovered orbiting the star. The planet is a gas giant, orbiting its host star every 1.61 Earth years. The other star, Castor, is located some 51 light-years away, and it's actually a system of 6 stars comprising 3 eclipsing binaries. Eclipsing binaries are binary star systems in which the orbital plane of the 2 stars in the system lies so nearly along the line of sight from the observer here on Earth that the stars appear to eclipse each other. Looking to the northeast now, and you'll see the star Regulus, or Little King, the brightest star in the constellation Leo the Lion. Leo is mentioned by Homer in his famous 8th century BCE poem, the Odyssey. According to Greek mythology, Leo was killed by Hercules as the first of his 12 labours. Located some 79 light-years away, Regulus is a multiple star system composed of at least 4 stars. Regulus A, designated Alpha Leonis, is a spectroscopic binary comprising a rapidly spinning spectral type B blue-white star around 3.5 times more massive than the Sun, with some 288 times the Sun's luminosity, and a small companion star, most likely a white dwarf, the stellar corpse of what once would have been a Sun-like star. The pair take about 40 days to orbit each other. Spectroscopic binaries are double-star systems orbiting each other so closely and at such an angle that they can only be visually separated, from our viewpoint here on Earth at least, by their spectroscopic signatures. Astronomers describe stars in terms of spectral types. It's a classification system based on temperature and characteristics. The hottest, most massive and most luminous stars are known as spectral type O blue stars. They're followed by spectral type B blue-white stars, then spectral type A white stars, spectral type F whitish-yellow stars, then spectral type G yellow stars. That's where our Sun fits in. Then there's spectral type K orange stars, and the coolest and least massive of all stars are spectral type M red stars, commonly referred to as red dwarfs. Each spectral classification system is further subdivided using a numeric digit to represent temperature, with 0 being the hottest and 9 the coolest. And then you add a Roman numeral to represent luminosity. So, our Sun, technically, is a G2V or G25 yellow dwarf star. Also included in the stellar classification system are spectral types L, T and Y, which are assigned to failed stars known as brown dwarfs, some of which were born as spectral type M red dwarf stars but became brown dwarfs after losing some of their mass. Brown dwarfs fit into a unique category between the largest planets, which can have around 13 times the mass of Jupiter, and the smallest spectral type M red dwarf stars, which are around 75 to 80 times the mass of Jupiter, or about 0.08 solar masses. The primary star in Alpha Leonis completes a full rotation around its axis in under 16 hours. That's incredibly quick, especially when compared to our Sun's 30-day rotational period. Now, this gives the primary star an oblate appearance, and it causes what's known as gravity darkening, meaning its poles are considerably hotter and 5 times brighter per unit surface area than its equatorial region. Scientists estimate that if it were rotating just 15% faster, the star's gravity would be insufficient to hold it together, and it would literally spin itself apart. Located further away are Regulus B, C and D, which are all dim main sequence stars. Main sequence stars are those undergoing hydrogen fusion into helium in their core, like the Sun's currently doing. Regulus B and C are thought to orbit each other every 600 Earth years and are located around 5,000 astronomical units away from Regulus A. An astronomical unit is the average distance between the Earth and the Sun, around 150 million kilometres or 8.3 light minutes. Regulus B is a spectral type F white-yellow star, while its companion Regulus C is a small spectral type M red dwarf star. Regulus D is a bit more of a question mark. It's a dim star, and, at least from our point of view, it appears to be sharing motion across the sky with other members in the group. At the opposite end of the constellation of Regulus is the star Beta Leonis, or the nebula, the horse's tail. It's a luminous white star thought to be spectral type A, about half as bright as Regulus, and the third brightest star in the constellation Leo. Beta Leonis has about 1.8 times the mass of the Sun and about 15 times the Sun's luminosity. It's suspected of being a dwarf Cepheid or Eta Scuti type variable star, meaning its luminosity varies very slightly over a period of several hours due to pulsations on its surface. Also at the other end of Leo are the stars Theta and Iota Leonis, the loins of the lion. Theta Leonis is about 165 light-years away. It's a very young spectral type A white star, about 2.5 times the mass of the Sun. With an age of just 550 million years, Theta Leonis' spectra shows enhanced absorption lines for metals, that is, elements other than hydrogen and helium. This increased metallicity appears around 12% higher than the Sun, allowing the star to radiate with some 141 times the luminosity of the Sun from its outer atmosphere, at an effective temperature of 9,350 Kelvin, literally giving it a white-hot glow. Located some 79 light-years away, Iota Leonis is another spectroscopic binary, consisting of two stars orbiting each other every 183 Earth-years. The primary star is a spectral type F yellow dwarf star, a little hotter and more massive than the Sun. Algebra, or Gamma Leonis, is a binary star system with a visible third component. The two primary stars are located 126 light-years away and can be resolved in a backyard telescope. Both are yellow giants, orbiting each other every 600 Earth days. The unrelated tertiary star, named 40 Leonis, is a yellow tin star which can be seen through binoculars. Its traditional name, Algebra, means the forehead. Other stars in the system include Delta Leonis, or Zosma, which is a blue-white star 58 light-years from Earth, Epsilon Leonis, a yellow giant some 251 light-years from Earth, and Zeta Leonis, an optical triple star. The brightest component is a white giant about 260 light-years from Earth, while the second brightest star, 39 Leonis, is widely spaced and is located to the south of the primary, with the third and faintest star in the system, 35 Leonis, located to the north. Also located in Leo is Tau Leonis, visible as a double star through binoculars. It includes a yellow giant located some 621 light-years from Earth, and a binary secondary star 54 Leonis, a pair of blue-white stars that are visible in small telescopes and located 289 light-years from Earth. Also in the constellation Leo, you'll find the Leo triplet, a group of 3 galaxies, Messier 65, Messier 66, and NGC 3628, all appearing relatively close together. Messier 65, also known as NGC 3623, is an intermediate spiral, or possibly barred spiral galaxy, about 37 million light-years away. M65 disk appears to be slightly warped, and a relatively recent burst of star formation is suggestive of some gravitational interaction with the other 2 galaxies in the Leo triplet, possibly around 800 million years ago. Nearby is Messier 66, or NGC 3627. Another intermediate spiral galaxy, some 95,000 light-years wide and about 36 million light-years away. Gravitational interaction from its past encounters with the neighbouring galaxies in the triplet has resulted in an extremely high central mass concentration, a high molecular to atomic mass ratio, and a resolved non-rotating clump of neutral atomic hydrogen apparently removed from one of its spiral arms. The third member in the group is NGC 3628, the Hamburger Galaxy, a spiral galaxy with a spectacular 300,000 light-year long tidal trail of gas and stars. NGC 3628 is located 35 million light-years away. Its most conspicuous feature is the broad and obscuring band of dust located along the outer edge of its spiral arms, effectively transecting the galaxy to the view from Earth. Messier 95 and Messier 96 are both spiral galaxies, each around 20 million light-years from Earth. M95 is a barred spiral. Another barred spiral, NGC 2903, is thought to be similar in size and structure to our own Milky Way galaxy. It was discovered by William Herschel in 1789. Close to the M95-M96 pair is the elliptical galaxy M105, which is also around 20 million light-years from Earth. Okay, let's turn to the east now and the constellation of Corvus the Crow. In Greek mythology, Corvus was a really clever crow. In fact, he could talk to people. However, after refusing to speak to the god Apollo, he was banished to the sky, together with Crater the Cup and Hydra the Snake. One of the brightest stars in Hydra is Alphard, the solitary one, so named because it appears all alone in the sky. Okay, turning to the western horizon now, and you'll see the star Achernar in the southern tip of the constellation Eridanus the River. Eridanus is one of the largest and longest constellations in the sky. Achernar means the river's end, as it marks the end of the river Eridanus. Located around 139 light-years away, Achernar is a binary star system, comprising two stars, Alpha Eridani A and Alpha Eridani B. One of the 10 apparent brightest stars in the night sky, Alpha Eridani A is a young, hot spectral type B blue star, about 6.7 times the mass of the Sun, with a stunning 3,150 times the Sun's luminosity. Achenar's extremely high rotational velocity of over 16 km per second gives it an oblate shape, making it one of the least spherical stars in the Milky Way, with an equatorial diameter some 56% greater than its polar diameter. This distorted shape means the star displays significant latitudinal temperature variations, with its polar temperature being above 20,000 Kelvin, while its equatorial temperature, being much further away from the stellar core, is only around 10,000 Kelvin. Those high polar temperatures are generating a fast polar wind, ejecting matter from the star and generating a polar envelope of hot gas and plasma. The companion star, Alpha Eridani B, appears to be a spectral type A white star with about twice the mass of the Sun. The two stars orbit each other at an average distance of roughly 12.3 astronomical units. Now, just a quick reminder that March 14th marks the yearly celebration of the mathematical constant pi. Pi is the ratio of a circle's circumference to its diameter. But it's also an irrational number, meaning its decimal representation never ends and never repeats. More than just a number, pi has important applications in astrophysics, orbital mechanics, and other fields of astronomy. It's been calculated to over 1 trillion digits, and the current record for reciting pi from memory is over 70,000 digits. Imagine sitting next to that person at a dinner party. As for me, 3.14159 is about it. Of course, as well as Pi Day, March 14 is also the birthday of the great Professor Dr. Albert Einstein. Joining us now with a further look at what's happening in the March night skies is Jonathan Nally, the editor of Australian Sky and Telescope magazine.
G'day, Stuart. Well, we're heading into autumn now here in the southern hemisphere and, of course, spring in the northern hemisphere. That means, for us in the south, we're heading into longer hours of darkness or stargazing, and our friends up in the north are heading into shorter nighttime hours as they head towards summer, therefore not so many hours of stargazing available. We normally start our tour of the southern sky in the south, but this time we'll start with the view to the north, as seen from the Australasian and South Pacific perspective. So, low down in the northern part of the sky, we've got 4 constellations of the zodiac, one after the other. You've got Taurus, you've got Gemini, Cancer, and Leo. Cancer and Leo, nothing really special to look at with the naked eye. There's not really bright stars in them and nothing much to see. They just look like a join the dot affair, and there's pretty bare sort of sky. But Taurus and Gemini are really good, really, really good. You can easily tell Gemini because there are 2 bright stars close together. They're called Castor and Pollux, and they stand out really well, and that's part of the constellation of Gemini. If you have a pair of binoculars, you can see a really nice star cluster in Gemini called Messier 35. This is named after a French fellow astronomer from a long time back called Charles Messier, who made a list of things that he saw in the sky. He was actually hunting for comets, and there are things in the sky like star clusters that can masquerade as comets if you just quickly look at them and you don't know what you're looking at. So he made this list, actually, which has become a famous list of fantastic things to see in the night sky. He made the list because he considered them to be a list of nuisances, and these are things to avoid. Yeah, if you want to look for comets. So if you're looking for comets and you see one of these, just ignore it. It's just something dull, Keep looking for comets. So anyway, Messier 35, it's a beautiful star cluster. You should be able to see a dozen or so stars with a pair of binoculars, but you can even see it just with the naked eye. It just looks like a small fuzzy patch of light, but with no individual stars visible. Just right next to Gemini is Taurus, constellation Taurus, and it has a bright red star called Aldebaran. And it's a really beautiful constellation, this, because it's sort of shaped like a wedge, and it has 2 really famous, fabulous star clusters. The wedge part that I described That's a star cluster called the Hyades, right? Hyades. It's a beautiful open cluster of stars, and it mostly forms this sort of wedge shape with the star Aldebaran in one corner. And the other star cluster that is in Taurus, of course, is one we've mentioned so many times. It's the Seven Sisters, or the Pleiades, which is just the most glorious sight. You can make out a few stars with the naked eye and get a pair of binoculars onto it or a telescope, and you can see lots and lots more. Above Taurus, again, we're looking from the south here. Above Taurus, you've got the mighty Orion, one of the best-known constellations. Grab the opportunity to see it now, because in a couple of months' time, it'll be gone. It'll have dropped below the western horizon after sunset. We won't see it again until much later in the year. For us in the south, high overhead this time of year are the two brightest stars in the night sky. You've got Sirius and Canopus. Sirius is a double star system. The larger of its two stars and that's the one we can see, is twice as massive as the Sun. And its apparent brightness, the Sirius star's apparent brightness, so how it appears to us at this distance, is about twice that of Canopus. So it seems much brighter than Canopus. But in fact, Canopus is about 4 times more massive than Sirius, and intrinsically it's much, much brighter. It just seems dimmer because it's a lot further away. Canopus is 310 light years away from us, whereas Sirius, which is a smaller star, is only 8.6 light years away, though it's closer, so it looks brighter. Sweeping south further along the Milky Way, past Sirius and Canopus, we come to the far southern constellations, such as the Southern Cross and Carina. You've got the Cross at the moment lying on its left-hand side in mid-evening in March. But if you're up and about in the early hours of the morning, about 2:30 or 3 or so, you'll find it much higher in the sky and standing up straight. That's just because the Earth has rotated a bit, so the angles are different. As far as the planets go for this month, we've got Mars is the one to watch at the moment, at least in the evening sky. You'll find it in the northwestern part of the sky, and it looks just like a sort of a medium brightness reddish star, but it's actually a planet, of course. And for the first week of March, it'll be very close to that Seven Sister star cluster I mentioned. So it should be pretty easy to see. Look for a reddish-looking medium brightness star with a little cluster of stars just near it, and that's Mars, and that's the Seven Sisters. All the other planetary activity is in the morning sky at the moment, so you'll have to be up before dawn, or if you're an early riser. What you'll see at the start of March is 3 planets in a row, sort of all one on top of each other, out there towards the east. You've got Saturn on top, Mercury in the middle, and Jupiter below. Jupiter's the brightest one, Saturn is the next brightest, and Mercury's a lot dimmer. Over the course of the next few weeks, they'll appear to shift position as the line of sight between Earth and each of the planets changes. So they are moving in their orbits, of course, and we're moving in our orbit. So the line of sight between all of us changes a little bit, and that means they sort of come a bit closer together or move further apart as seen in the sky. They're actually a long way apart out there in space, of course. On March the 5th and the 6th, actually, something really good. If you're up early and you've got some clear skies, go out and have a look to the east, because you'll see Mercury and Jupiter right next to each other. That's because Mercury will have dropped down a little bit lower towards the horizon where Jupiter is, and they'll be right next to each other. Should be pretty specky. As the month goes on, Saturn and Jupiter will both rise higher and higher in the sky and continue to do so for weeks ahead. But Mercury is going to drop lower and lower down towards the horizon this month, and eventually it'll be lost to view. And if you're wondering where you can see Venus, I'm sorry, but at the moment you can't. Nothing I can do about that. It's around the other side of the sun from us, and it won't be back in our skies until May. That's about it for March, other than a reminder that the equinox, of course, will occur on March the 20th this year. Equinox is when the sun is directly above the equator, and it's the day when you get almost equal hours of darkness and daylight. And in fact, that's exactly where the name comes from the Latin. The equi bit means equal, and the nox means night.
That's Jonathan Nally, the editor of Australian Sky and Telescope magazine. And don't forget, if you're having trouble getting your copy of Australian Sky and Telescope magazine from your usual retailer because of the current lockdown and travel restrictions, you can always get a print or digital subscription and have the magazine delivered directly to your letterbox or inbox. Subscribing's easy. Just go to skyandtelescope.com.au. That's skyandtelescope.com.au, and you'll never be left in the dark again. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. and you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more SpaceTime, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary. And SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.
Wells Fargo presents one of the surest ways to grow your money. A Wells Fargo CD account, where you can earn a 5.00% annual percentage yield on an 11-month term with a minimum opening deposit of $5,000. Visit a Wells Fargo branch or wellsfargo.com/CD rates to open a CD account and start growing your savings with us.
Wells Fargo Bank, N.A., member FDIC.
Hello, saver. Whether you're saving for that trip to the tropics or saving for an emergency, now is the time to take advantage of Wells Fargo's savings options. Wells Fargo offers savings accounts that can help you save towards your goals. So, what are you saving for? Visit a Wells Fargo branch or wellsfargo.com/save to open a savings account today.
Wells Fargo Bank, N.A., member FDIC.